Okay, so today we are going to identify even and odd functions and classify points of discontinuity. So we're going to start with the even-odd function. A function can be classified as even, odd, or neither. This classification can be determined graphically or algebraically. We are not doing it algebraically, so I cross that off. So the graphical interpretation is if you are an even function, you have a graph that is symmetrical about the y-axis, which means if you sandwich it on top of itself over the y-axis, it's exactly the same. The y-axis acts like a mirror. An odd function is a graph that is symmetric with respect to the origin. What that means is if I rotate this around upside down, the graph looks exactly the same. If neither of those things are true, then we classify it as neither odd or even. So here are a few more examples of even and odd functions. Okay, so just take a second and kind of look at those and imagine the y-axis sandwiched on top of itself, and the odd function, if you rotate it upside down, it would look exactly the same. Okay, so our first example here is this guy, and it's not even, and I don't know what that little orange dot is, so I apologize. It's not even because if I flip it on top of itself, we have this little part down in the negative y values is not going to be down the same on the other side. So I have the luxury though that I can actually rotate this 180 degrees and upside down, and does it look exactly the same? Does it look exactly the same? Oh my goodness, yes it does. So because if you flip it upside down it looks exactly the same, this is an odd function. Okay, over here we have a graph that if I were to sandwich itself over this y-axis and I just over, would it land on top of itself? You bet it would, so this is an even function. Okay, coming down here, here's another one that you might think it's odd because it's doing kind of the same thing as before, but if I actually rotate it, is it exactly the same? And I'll zoom it out again because it gets smaller. No, we're in the wrong quadrants now. Okay, so let me take it back. So see what quadrants we're in? We're in 1 and 4. And then if I rotate it, now we're in quadrants 2 and 3. So no, this is neither even or odd. And I do want to caution you that not every quadratic function is even. Some students believe that, but here's my y-axis. If you sandwich it on top of each other, is it identical? No, so this one is neither. Okay, so that's even and odd. Now we're going to go back up and talk about discontinuities. Okay, there are 3 types of discontinuities: infinite, removable, think patch a hole, and I'll explain, and jump. Okay, so here's our first example. So I have this graph, and discontinuities are breaks in the graph. So to be a continuous function, the age-old, if you're drawing the graph with your pencil, you can't pick up your pencil. There are no breaks or holes. In calculus, you'll get a more formal definition. So as I'm going along and I'm drawing my graph, I'm going along, and then I have to pick up my pencil here because there's a hole. So x equals 2, negative 2 is my first point of discontinuity. And then I go along. Oh, I have to pick up my pencil to get to the other side because this is going to keep going down forever. So x equals 1 is my next point of discontinuity. Going along, and I'm good, okay? So now we have to classify our discontinuities. So this first one at x equals 1, this one is going to be broken forever. It's going to keep going on forever and ever and never get to fix there. So we call that infinite when it just keeps getting broken forever and ever. At x equals negative 2, there's a single little hole. So if I wanted to, I could patch that hole by filling it with one specific point. Because I can patch that hole with one specific point, we call that removable, which means we can remove that discontinuity by patching that hole. You'll learn more about that in calculus. So here's another example. So as I'm going along, ooh, we have to actually jump up here. Okay, so that is a discontinuity at x equals negative 3. Then I continue along. Oh, there's a hole. I have to jump over it. So that's x equals 1 is a discontinuity. Continue. Oh, jump over 6 to get to the other part. So x equals 6 is another point of discontinuity. So at x equals 6, because the arrows are going to go forever and ever, we call that one infinite. Okay, at x equals 1, there's a singular little hole to patch, and I can keep going if I wanted to, so we call that one removable. We could fix that with one single dot. Now, x equals -3. This one you actually have to jump a lot of y values to keep going. There is not a single hole. If I tried to like fill that hole, we're still not connecting the graphs. So when you see this, this one is called a jump. You literally have to jump to continue along the path. Okay, one final example here. Okay, so x equals -4. There's a hole there. X equals 1. And x equals 4. Okay, so as I'm going along at x equals -4, there's a singular hole that we can patch, so we're going to call that removable. As I'm going along and going along, I see at x equals 1, even if I tried to patch that hole, there's still that gap. I have to jump to continue going, so that is a jump. Okay, now at x equals 4, this is the tricky one. Students like to call it a jump because of this dot down here. But that's not true. As I'm going along, going along, going along, I could kind of just shift that dot and fill it and continue going along. This one is actually removable as well because we can patch that singular hole by moving that one specific dot and filling it in, and filling in a pothole. Okay, so there you have it. Practice on the worksheet and reach out if you have questions.